Okay, hi friends. So first today we will see the causes of tides and then one more example of secondary port from volume 2 or 3. Last video we saw the example from volume 1. So again we have already discussed some idea about causes of tides. It's just refreshing. So this is the earth and this is the water level of the earth, then this is the moon, and moon is now in new moon phase because the sun's rays are falling here, and this side there are no rays, so it will, anyone from earth can see this part where there is, you cannot see the moon, that is called new moon. So as we know, the moon rotates anti-clockwise around the earth. So from here the moon will go here, which is called first quarter. Now here we can see the half moon, this part where the sun rays are falling, and this half we cannot see, and this half is beyond our vision. So when it was new moon, there was a pull from the moon, the gravitational pull, and the sun was also pulling. So lot of water you can see is going here, and there is very less water left here. So the total water is same. So this is called spring, where there is lot of water is coming here and very low water is left here. So in spring, the high water will be very high and low water will be very low. That's why we are doing this revision to see this. Now in when it is first quarter, again the pull will be there, but moon's pull is this side and sun's pull is this side, 90 degree. That is what is called quarter or quadrature. So here it is called in conjunction or in line, and if it is coming here it will be in opposition, and here it is quadrature. So this is quadrature. You can see the pull is this much, and here the low water is more than this low water, and this is called neap. So in quadrature, the tides are called neap tides, where low water of neap is more than the low water of spring, and high water of neap is lower than the high water of spring. So both low water and high water is of lesser magnitude. So in quadrature, here and here is neap, and there it is spring. Now again it is coming to full moon. So tell me which tide it will be. It will be spring, correct. So it is, again you can see same way in opposition, very high water and very low water. And same way here, this is there are different causes of tides. One is rotation of earth, one is rotation of earth on its axis, one is rotation of moon around the earth, and then third is earth is rotating around the sun. So first we saw the rotation of moon. Now we will see the rotation of earth and the rotation of moon. So because of the rotation of earth and moon, the tide timings are always, if the earth was not rotating, only moon was rotating, then we would have tide at every 6 hours like this. So moon is taking total 360 degree. So in 1 hour it will take 15 degrees. So for 90 degrees it will take around 6 hours. So if first it will be here, then it will go here 6 hours. So the high water will be here. If this person is here, now it is having low water. When the moon comes here, he will have high water. Then when he comes here, it will have low water again and high water. So every 6 hours, 0, 0, 0, 6, 0, 1200 and 1800, the tides would change. But that is not happening. Every day we have a change of 50 minutes. Suppose today the high tide was 0600. Tomorrow the tide will be at 0650. Why? We will see now. So we take this person. This person is here at A, and the moon is here. Now this earth is rotating at its axis. So this earth is rotating, and this person here, this person at 000 was having high tide. Now this person, the earth rotates, and this person reaches at this place after 6 hours. So after 6 hours, 15 degrees per hour, so it will reach 90 degree, and it will have low water because it's very far away from the moon. Now, after 12 hours, this person reaches here. Again, he will have high water approximately. But moon has shifted a little bit up. So there will be around 25 minutes lag. So he will have high water not at 12 hours, but 12 hours, 25 minutes. Same way, when he moves here, he will have approximately low water at 18 hours, around 35 minutes something. And then when he reaches here, so if the earth was not rotating, he would have high water here if the moon was still here, if the moon was not moving. But now the moon has moved from here to here, and that much time when the earth will move till here to get high water, that will be around 50 minutes. So instead of 0000 again, where it was high tide, we will have high tide at 0050. This is the 50 minutes lag of the what you call moon. Now we will do the next problem from 880 volume 2 and 3, which is for Mina Al-Ahmadi. So same thing, we will be given from standard ports. You can take out the timings, and so from ATT volume 2, we will get from the tables, part 3 from the traditional tables, time difference and height difference. So now you can see that for Mina Al-Ahmadi, this time difference is not given and height difference is given. So for time, finding the time difference, directly apply the above time difference for high water and low water in secondary port, and no interpolation needed, because if time difference is not given, you just apply. This means the correction for Ras, we want to find the tide for Ras Al Khafji, and Mina Al Ahmadi is the standard port for that. So since time duration is not given for all, that means for all the time correction is this much only. And for height difference is given, so we will apply that. Now for finding the height difference, first, same like we did in previous, we apply the reverse seasonal correction to the standard port, and the whatever value we get, that we interpolate from this, or we can even extrapolate as we discussed for this in height. Then we apply the seasonal correction for the secondary port, and we will get the height. Now step number 3 is we need to find the height between the above obtained high water and low water time and ranges, and apply it to the general tide curve. So whatever correction we will get, that we will apply to the tide given for that day, which is called daily prediction. And then we will get the tides and timing for the secondary port. But if we want to find the intermediate time between, apart from the daily prediction, intermediate heights and time, which is called, then we have to first see that the range of time between these tides which have come, timings, is between 5 to 7 hours. Then we will draw the approximate curve with pencil on this diagram. So let's see how we will draw this curve. So for volume 2 and 3, there will be only one curve. Like for volume 1, we had the separate curve, separate graph for each standard port. But in volume 2 and 3, there will be only one curve for full book. Volume 2, there will be one curve, and volume 3, full book, there will be one curve. And the curves will be like this. So it will be from 5 hours, 6 hours, and 7 hours. So suppose the time range is 5.5 hours, and that we have to also see if the tide is rising or falling. So this is rising tide, and this is falling tide, and this is high water. So this is 5 minus means 5 hours before high water, and this is 5 hours plus, means 5 hours, 6 hours and 7 hours after high water. So suppose the tide was rising. We will see later on how to see that. If the tide was rising, we will use this side of graph. And if the tidal range time is 5.5 hours, then we will make a rough hand graph between 5 and 6. That will be around 5.5 and like this. Now suppose the tide range was 6.3 hours, that is 6 hours 18 minutes, and it was falling tide or ebb tide. Falling tide is also called ebb tide, and rising tide is also called flood tide. So since it was ebb tide or falling tide, we will use right hand side of graph, and 6 hours 80 minutes. So this part will divide approximately in 3 parts. This will be, we'll draw a rough hand sketch, which is like this: 6 hours 18 minutes. Then you can write this formula: maximum draft plus UKC is equal to charted depth plus height of tide. This we will use in the next when we are doing the height problems. So that's it for today. Next next video will be about the height problems in the tides. Thank you. If you have any questions, you can ask.